This is section 1.1 in algebra, and it covers variables. The vocabulary that you have for this section is the following. The term variable in algebra, it's a symbol that we use to hold the place for a number that is not known at the moment. For example, for x, the x holds the place of some number, and in 3a, b, c, the a, the b, and the c each hold a place for numbers. A variable expression is a math expression that has at least one variable. For example, the expression 9a equals 25 is a variable expression because it has a, the variable. If you're asked to evaluate an expression, they want you to solve it. If you have a problem like 9a equals 18 and you're to evaluate it, the problem would give you the value of the variable. So a is 2. So 9 times 2 would be 18. The value of the variable is the number that will replace the variable. So if you have an expression like 3x, and if someone was asking you to evaluate, they would have to tell you that x is the value, has the value of 3. In algebra, we have to have other ways of showing multiplication besides the times sign, since the x looks like the variable x. So instead of using x, if I wanted to show 6 times 3 in algebra, I could use a dot. I can also use pairs of parentheses. For example, 6 times the quantity y plus 3, that means 6 times the sum of y plus 3. If I have a number in a variable, that also means multiplication, so it would take 6 times whatever y is. If I have variables without any operation between them, that means multiplication, so xy is the same as x times y. Also, pairs of parentheses can be used to indicate multiplication, so this is 4 times 3. A numerical expression is a math expression that does not have any variables. For example, the expression 30 divided by 5 equals 6 is a numerical expression. Numerical expressions, if their equations can be evaluated as true or false, in this case 30 divided by 5 is 6, and 6 does equal 6, so that's a true statement. Sometimes we need to make a statement that something is not equal to something else, and to do the not, we just use a slash. So here is the equal sign with a slash, that means not equal to. So this numerical expression 3 plus 2 does not equal 6 is true, because 3 plus 2 is 5, and 5 does not equal 6. The slash can also be used with other symbols, relation symbols in math. For example, I could take the greater than sign and put a slash through that, and it says not greater than. Less than sign with a slash means not less than. If the directions say to simplify, that means to get the answer in the simplest form possible. In math, that generally means as few numbered terms as possible. So here I have 5x plus 3x, and that can be simplified by adding these together and getting 8x, and 8x is only one term, whereas these two make 2 terms. So that's the simplest form for that expression. The substitution principle sounds formal, but it's something you've been doing in math since you've been able to count. If I had 1 plus 1, I could say 2, and that's the substitution principle. I replace 1 plus 1 with the number 2. So if you can replace any expression with an equivalent expression, that's using the substitution principle. A little testing on what we just went through. What do you call these two types of algebraic expressions? Well, the first one is a variable expression. You said that, good. It has variables in it. The second one is since it has no variables, a numerical expression. And then the next one, is this a true statement? Since it's a numerical statement, if you remember, I said you can always tell if a numerical statement is true or false by evaluating it. So the left side is 7, we have not equal to, and the right side is 6 plus using grouping symbols first, 1. So we get 7 does not equal 7. And that's a false statement, because 7 does equal 7. And then the majority of your problems that you're going to be doing in your assignment are going to be asking you to evaluate variable expressions. So they'll tell you the values of the variables. For example, in these 4 problems, x is 3, y is 5, and z is 0. So evaluating these expressions, yz means to take y, which is 5, times z, which is 0, and evaluating it, that we get 0. Second expression has 8 plus 4 times x, and x is 3. So 4 times 3, we do multiplication first in order of operations, so that'd be 8 plus 12, which is 20. The next expression, 2 times y minus 3 times z. 2y is 2 times 5. Minus 3 times z, which is 0. We could use parentheses here to make this clearer. So that's 10 minus 0, which equals 10. And the last expression is actually a division problem. The numerator, y plus z, would be 5 plus 0. And the denominator is y minus z, so that'd be 5 minus 0. The fraction bar acts like a grouping symbol, so we do what's on top first. 5 plus 0 is 5. And 5 minus 0 is 5. And 5 divided by 5 is 1. Be sure to get your vocabulary into your notebook. Your assignment for tomorrow is to do the evens on page 3, written 1 to 30. So have your paper headed. Skip a line, put the title, skip a line, and the even problems are those that you do from the video are to be on the left side of your paper, and when you fold your paper, you do on the right side, you put the ones that you're doing in class, which are generally the odds. On page 3 at the bottom of the page are the written exercises, and the directions say to simplify each expression so we get it into as few terms as possible. And for these, since they're all numerical expressions, you need to use your order of operations. So number 2, copy the problem down. It's 9 plus the quantity, which means parentheses, 18 minus 2. In order of operations, we do grouping symbols first, so 18 minus 2 is 16. Now we add 9 plus 16 equals 25, and circle your answer. Skip a line. Problem number 4, and copy it down, it's 13 minus 6. The quantity minus 7. Doing grouping symbols first, we get 7 minus 7, which equals 0. Problem number 6, copy the problem down, it's 6 plus the quantity, 12 divided by 3. We do grouping symbols first, so 12 divided by 3 is 4. 6 plus 4 is 10. Skip a line, number 8, copy the problem down. You have 5 minus the quantity 16 divided by 4. Doing what's in grouping symbols first, 16 divided by 4 is 4. Now subtract 5 minus 4 equals 1. Skip a line, copy number 10 down. 10, you have the quantity 12 times 11 minus the quantity 2 times 11. We do grouping symbols first, we get 132 minus 22, which is 110. Make a note here on this, that there is another way we could have done this problem. If you remember the distributive property, I can see the 11 is used twice. So I could take and put what it was used with, 12 minus 2 in parentheses, and times it by the 11. So I get 10 times 11, which is 110. That is another way of doing it. Number 12, copy the problem down if you skip a line. You have 40 divided by 10, the quantity. divided by the quantity 1 times 4. 40 divided by 10 is 4, and 1 times 4 is 4, and 4 divided by 4 equals 1. Number 14, other directions. Change, we're to evaluate each expression if x is 2, y is 3, and z is 4. So 14, we copy the problem down at 6y, which means 6 times y. The value for y is 3, so substitute that in, we get 6 times 3, which is equal to 18. Skip a line, number 16. The problem is yz, which means y times z. The value for y is 3, z is 4, so we have 3 times 4, which equals 12. Skip a line, number 18. We have the quantity 3y minus 9. Substitute 3 in for y, so we have 3 times 3. 3y means 3 times y. Minus 9. Order of operations, grouping first. 3 times 3 is 9. 9 take away 9 is 0. Problem number 20. You have the quantity 8x plus 7. Substitute in the value for x, which is 2. So now we have 8 times 2 plus 7. Doing what's in parentheses first, we get 16 plus 7, and adding we get 23. Skip a line, we have 22. The quantity 3z minus the quantity 4x. Substitute the values in for z and x. Z is 4, so we have 3 times 4 in parentheses minus 4x, 4 times 2. 3 times 4 is 12, 4 times 2 is 8, and 12 minus 8 is 4. Problem number 24. We have 7 times the quantity y minus x. Substituting the values in for y and x, we get 7 times the quantity 3 minus 2. Working out what's in parentheses first, 3 minus 2 is 1. 7 times 1 is 7. Problem number 26. We have 2/3 times the quantity y plus 6. Substituting in the value for y, which is 3, and adding it to 6. Please remember to use 2 lines for fractions so we don't have the work crowded and it's easier for you to read. 3 plus 6 is 9, so we have 2/3 times 9. And we can cancel here. So 3 goes into 3 once, and 3 into 9, 3. So our answer is 6. Number 28, we have the quantity x plus y divided by the quantity x minus y. This is very similar to the one I did for the examples. So in parentheses on top, it'd be x plus y, which would be 2 plus 3. And on the bottom, you have x minus y, which is 2 minus 3. So 2 plus 3 is 5, and 2 minus 3 is negative 1. Whoops, I'm sorry, we'll have to go back and fix that one. I had the wrong numbers in there, so we'll just erase those. I had x and it should be z. Okay, so now we have z plus y and z minus y. And z is 4 plus 3, and z is 4 minus 3. So now we have 7 over 1, and 7 divided by 1 is 7. And problem number 30. we have 4z minus the quantity 8x. So we take 4 times z, and z is 4, minus 8 times x, and x is 2. So we can go left to right here, except don't do the subtraction until the end. So 4 times 4 is 16, minus parentheses next 16, so we get the answer 0. And that's the end of the evens. Don't forget tomorrow that we will have a practice drill, and since we just started the chapter 1, the drill will be over basic operations with fractions, such as adding, subtracting, multiplying, and dividing. And a little quick review on that. If you, we'll probably just do addition of fractions. So if you add two fractions together, like 1/6, I'm having trouble with 6, plus 2/6, as long as the denominator is the same, we add and we get 3/6. And then simplify, which is 1/2. If I had 5/6 plus 2/6 and added that, got 7/6. For algebra, you can leave them in improper fraction form unless I ask you to change them into a mixed number, which would be 6 goes into 7 once, and you have 1 left over, so it'd be 1 1/6. If you have different denominators with addition, such as 2/3 plus 4/5, you find the least common denominator of 3 and 5. So the smallest number that 3 and 5 both go into would be 15, and you would rename them. 3 goes into 15 5 times. 5 times 2 is 10. And 5 goes into 15 3, and 3 times 4 is 12. So we would have 22 15ths. And you can leave it like that, or if you change it to a mixed number, 15 goes into 22 once, with 7 left over. There's 1 15 and 22, and it'd be 1 7/15. Always remember, if you get a fraction that needs to be simplified, if you come up with an answer such as 10 15ths, you need to simplify it always. So you find your greatest common factor, the largest number that goes into 10 and 15, which is 5, goes in twice in 15, 3. So we'll have the drill just over basic addition of proper fractions. We can do the mixed numbers in the next drill. So be ready for that tomorrow, and make sure you have gone over your vocabulary, because those should also be on the vocab check. And that's the end.